These are your 12.3C notes on exact trig values of the trigonometric functions. We're going to tie in everything we've done up to this point in section 12.3. So we're going to draw the angle, we're going to find theta prime, and then eventually, not only are we going to recognize what the reference angle is, we're going to find one of the 6 trig values of that reference angle. So to do so, you're going to find the reference angle of theta. You're going to find the trig function for that reference angle, and then we have to determine the sign of the function of the original angle. So I have this chart down here, and if you remember from point trigonometry a few days back, when we plotted the point, depending on what the ordered pairs were, some had a negative x value or a negative y value, that brought in a negative trig value, but they weren't all negative. So I'm going to demonstrate in class where these signs come about. But I just want you guys to actually go ahead and copy down all of these signs. So in quadrant 1, you can notice going down that column, all 6 trig values are positive. And I'm just going to talk in terms of sine, cosine, tangent, and just understand that they're buddies. The cosecant, secant, and cotangent also apply. If the original was positive, the inverse is also going to be positive. In quadrant 2, sine was positive, cosine and tangent were both negative. In quadrant 3, tangent was the one that was positive and the other 2 were negative. And in quadrant 4, cosine was positive and the other 2 were negative. So if you can see here, besides quadrant 1, where we've got all 3 positive, or all 6 positive, each one takes a turn being positive in all the other quadrants. So sine gets to be positive in quadrant 2, tangent's the one that's positive in quadrant 3, and cosine gets a chance to be positive in quadrant 4. And so what this introduces is the cast method or the cast system. Okay, and it's just a play on words. In the first quadrant, this is quadrant 1, all of them, all 6 trig values are positive. In quadrant 2, just the sine and cosecant are positive. So we're going to write an S there to tell us that sine and cosecant are positive in the second quadrant. In the third quadrant, quadrant 3 down here, tangent is positive. And in quadrant 4, it's cosine's turn and secant's. So you can see where the word cast comes from. The problem with cast, I'm not a big fan of the fact that it starts in the 4th quadrant. So what I fear is that you're going to put the C in quadrant 1 and spin around and you get everything wrong. So another way to think of cast is I think of it, just come up with a sentence that starts in the 1st quadrant, like all students take calculus. And those are the same letters, but that's a sentence that starts in quadrant 1 and works around. So we're going to pull all of this together. I'm going to show you the exact way that all of your work should look. You are going to want your circle diagram sheet that has all those exact trig values at the very bottom of your table. So the very first thing we do is we draw the angle, just like we've done before. So sine of 135 is in the 2nd quadrant. You might want to do some preliminary math, but I see that it ends in 5, so that tells me that it's a 45-degree angle. And so when I draw my sine 135, I'm going to put it right in the middle of quadrant 2. I'm going to draw my directional arrow showing that it was a positive angle going counterclockwise, and I'm going to label it in degrees. I'm going to bring in my reference angle, theta prime, and I'm going to draw a reference triangle. These two things are critical because you can't really describe a reference angle until you draw it, so I know what you're talking about when you show your work in the next step. And you really can't do any trig unless you have a right triangle. So we have to bring in that right triangle to have a side opposite, adjacent, and the hypotenuse. So we just created a right triangle that correlates, references that obtuse 135-degree angle. We're going to show our theta prime work, which we did. So theta prime is equivalent to 180 degrees. Take away 135 degrees. Theta prime is a 45-degree angle. Now in this section, all of your answers have to become a positive 30, 45 or 60 degree acute angle. If they don't, we don't have the exact value for them. And so now we're all set to go. I know what theta prime is, so I'm going to write the next steps. This is just what we have to add on. Everything else we've done before. I'm going to say the sine of 135 degrees, so we're finding, yep, sine, is equivalent to or equal to the sine of a 45 degree angle in quadrant 2. I need all of that written down. The first part, the sine 135, is just sort of a label. So when I do my next line, this is the proper way to show your work in math, you just copy that down. So therefore, the sine of 135 degrees is equivalent to, I'm going to find sine 45 in my table of values. And the sine of 45 degrees is the square root of 2 over 2. That's the exact value. No buttons, no sign button, no decimals. Now where quadrant 2 comes into play is that I need to apply the cast system here. So I'm actually going to bring in the cast. So all students take calculus. By putting those letters in every single picture that you draw, it tells me that you applied the sign to every single problem. And so if I look, my angle is in the second quadrant, and in the second quadrant there's an S. And that S tells me that sine and cosecant are positive. Since we're finding the sine, this is a positive value. If we were finding anything else, it would be negative, except for cosecant. So that's your answer. So that's just the extra step that we have to take when doing our work.
Please excuse the interruption. At the balcony.
So let's go ahead. I'm going to actually leave number 2 for you. I'm going to have you guys show all of this work for number 2.
And also,
So I'm going to save number 2 for later. You guys are going to do that as your practice problem. So let's do 2 radian examples. So for number 3, we have the cotangent of 5/3 pi. The first thing we're going to do is draw that. So anytime I have to draw radians, I know you're not too familiar with radians. I'm going to look at that denominator, and I'm going to label this 3/3 pi, because that's 1 pi, and then 6/3 pi. And it kind of helps you figure out where 5/3 pi lies. It's in the 4th quadrant. The thirds tells me it's a 60 degree angle in the 3rd quadrant, so it's going to be further away from the x because it's 60 degrees. And so that's down here. And I'm going to draw my directional arrow. Make sure you put the arrowhead on there. And I'm going to label it in radians. I don't want to see any degrees in this problem. So there's your 5/3 pi. I'm going to bring in theta prime, label it, and I'm going to bring in my reference triangle. So I have a right triangle. Now I'm going to describe what theta prime is. So theta prime is equal to, since I'm in the 4th quadrant, I'm going to subtract from 2 pi, which in this case is 6/3 pi. So I really am trying to stress not using your calculator here. It's just easier using the fractions. So 6/3 is just the fraction form of 2 minus 5/3 pi is equal to pi over 3. I kind of knew it was 60 degrees before I even started, or pi over 3 before I even started. Now that I know the size of theta prime, I'm going to go ahead and find out what's my value. They want to know cotangent. So I'm going to do cotangent of 5/3 pi is equivalent to finding the cotangent of pi over 3 in quadrant 4. So the cotangent of 5/3 pi is equal to, if you look at your chart, the cotangent of 60 degrees or pi over 3 is the square root of 3 over 3. Since I'm in the 4th quadrant, I'm going to label all students take calculus. And the C in the 4th quadrant is telling me that cosine is positive. We are finding cotangent. So this is why this is negative. We force it to be negative. You have to do that every single time. Last problem, I want to show you an example of a negative angle measure. And it's a radians again. So this is in fourths. And so now that I see the denominator, I'm going to come over to my pi and write it as 4/4 pi. And on the other axis, I'm going to write that as 8/4 pi. So I know that negative 1/4 pi ends up being in the first or the fourth quadrant. So it's a 45-degree angle because of the fourths down here. And I'm going to show my directional angle that I didn't go all the way around. I actually just went 45 degrees clockwise. So negative pi over 4. So I have everything labeled. Theta prime actually is that angle. And remember, whenever we use our rules to find theta prime, they're kind of reversed for the negative. So you look at the negative and say, where would that be? Well, that angle would be in the first quadrant. It's already just a small acute angle, pi over 4. So I'm just going to write the statement that basically says that theta prime is going to be equivalent to theta. And so theta prime is pi over 4. It's technically the positive theta. That's really what it is. So now that I know it's pi over 4, I can bring in the actual trig, which I can't remember. We're doing cosecant. So the cosecant of negative pi over 4 is equivalent to cosecant of positive pi over 4, but we are in the fourth quadrant. So cosecant of negative pi over 4 is buddies with sine. So if the sine, if you look at your table of values, we should get the square root of 2 here. And it's in the fourth quadrant. So I'm going to look at my all students take calculus. I'm in the fourth quadrant. The C in this particular case stands for cosine. And cosine is not what we're finding. So we're going to make this negative. And there you have it. So your lesson summary, I need you to describe what each of those letters mean. Okay, not just the fact that they represent what trig value. What does that mean when we do cast? And then I need you to do example 2 right on that part. You don't have to do it here. You do it right under example 2 and show all your detailed work. Good luck.